Okay, sorry, I got cut off. I said that if it's a multiplication out here, it's going to either be a vertical stretch or compression. They don't show us this right here, so all I'm going to do is run over to, I don't know, let's go to your calculator and show you, or maybe Desmos. Desmos, I think, is easier. Let's go over to Desmos. So this is your parent function. This was shifting it down to. Let's see what we'll multiply by 3. 3 absolute value x. Okay, so we see that caused it to stretch taller. Okay, it didn't shift it any. It just caused it to stretch taller. Well, what happens, let me turn this one off. What happens if I multiply it not by a whole number, but by a fraction? Let's see if I multiply it by 1/3. Absolute value of x. Okay, you can see that this one at the point 1 right here, or it should say -1, it's at 0.33333. Well, you recognize that is 1/3, right? And where it was, the parent function was 2, 2. This function is 2. Oh, sorry, go here. This function is 2, -2, 2/3. Okay, so we took each one of these values right here and we divided it or multiplied it by 1/3. Okay, so that's what we call a compression. It got wider. Now, not all graphs are going to get more narrow and wider. You can't see. Let me show you what I mean. Okay, let's go back and delete all of these. Let's look at the graph x to the third. Okay, if you want to see a stretch, let's do 4. 4x to the third. Okay, so you see that one got taller because it got pulled taller, so it's moving closer to the y-axis, kind of the same way that the other ones did. So what do you think is going to happen if I do 1/4 x to the third? It compressed. They pressed it down. It got pressed closer to the x-axis. So when you stretch it, it gets taller, which means it gets closer to the y-axis in both directions. When you compress it, it's like you're pressing it down towards the x-axis and it gets closer to that. So compressions and shrinks are harder to see on some graphs, easier to see on others. Okay, but that's what we were looking at right here, a vertical stretch, and that's how you would tell. Now, how do you know it's a stretch or compression? Because there's multiplication right there. That's the parameter change is multiplication. Okay, well, you may be saying we've got multiplication right here. Yes, we do. It's multiplication by a -1, and that one is special. That gets its own special category. So we're going to put the parent function back on there. You should be getting very used to what the absolute value parent function looks like. Absolute value parent function. And when I do the table for that, a negative on the absolute value. Okay, so when I plug in -2, the absolute value of -2, forgot I have a pen. The absolute, oh, sorry, let me make that bigger again. The absolute value of -2, when you plug in -2 right there, the absolute value of -2 is +2. But then we got to multiply that times -1, so it stays -2. When we plug in -1, the absolute value of -1 is 1, and then we've got the negative on the out there that's making a -1. Plug in 0. Well, there is no such thing as -0, so it's 0, 0. Plug in 1. The absolute value of 1 is 1. but we got a negative out there. So what just happened was, over here, where everything was always positive, over here, everything's always negative. Okay, so what does that look like? It looks like this. Okay, there's, whoops, cut off a little bit. So what we call that is it's only, again, this is an outside change. It's an outside parameter. An outside parameter is always going to affect the graph vertical. And because it's a negative, we say it's a vertical reflection. Okay? Vertical reflection means it reflected over the x-axis. Okay? Because what was all positive y values now becomes negative y values, and we're reflecting it over that x-axis. Okay, let's see what's next. Okay, I want to do, before we go and tackle these inside changes, I want to maybe do a couple of more vertical changes. So let's go to, let's see, Desmos maybe? Let's go to Desmos and see if we can make some predictions, okay? Parent function. Okay, let's do something simple like y equals x. Okay, what does, and I hate that it's gonna, that's okay, 2x. Outside parameter change, it's multiplication, so we can see that it caused this line to stretch up. It got closer to the y-axis in both directions. See right here, it got closer to the y-axis here, it got closer to the y-axis right there. That's called a vertical compression. It's called a vertical stretch. What would I need if I wanted a vertical compression? My number right here would not be a number bigger than 1. It would have to be a number between 0 and 1. So in other words, it'd have to be a fraction. So I would need 1 divided by 2 to give me a vertical compression. Vertical compression got closer to the x-axis. Okay, it compressed it. It's like somebody sitting on it and squishing it down. All right, let's do another parent function. What other parent function could we do? X squared. X squared. Okay. Negative x squared. What do you expect to happen? That's right. You should have expected it to go down. Can we have a negative and a stretch? Absolutely. What about negative 3x squared? Okay. Negative 3x squared. You see, the parent function's up here. The negative made it go down. Okay, and it stretched by a factor of 3. Okay, so where it was crossing at negative 1, 1, or negative 1, negative 1, it's now crossing at negative 1, negative 3. So it reflected it and it stretched it. So you can have 2. Oh my word, you could have a whole bunch of them. You could have, let's see what's going to happen if I go up here and put plus 2 on the end of it. Whoops. Plus 2. So it reflected it upside down, it stretched it, and it also moved it up too. An outside change, outside change, outside. There's 3 parameter changes. The multiplication of negative 1, which reflected it, the multiplication of 3, which stretched it, and the add 2 to the outside, which caused it to translate or shift up. I can't believe I'm out of time again. Okay, so I got to stop and add another recording.